Hi, this is Gary Kayye. We're here at InfoComm 2021. And this is the third InfoComm, so fourth year that AV over IP has been a big deal. And we finally have a proposed standard, and I'm going to teach you about that a little bit while we're doing this interview. I'm here with Andrew Starks, who's the Director of Project Management for Macnica.
Yes, that's right, yeah. Hi, Gary.
How are you doing?
I'm doing great. The show's awesome.
Yep. And so Macnica is one of the companies that's an early adopter and supporter of IPMX, which is based on SMPTE 2110 standard.
Yeah.
Kind of put it in perspective as to what that means, because it is the only proposed standard for AV over IP. As you may know, there are ecosystems out there like SDVOE. Kind of Crestron's created their own ecosystem, you could say, because it's connected to their control system. Extron has their kind of ecosystem with NAV. But IPMX is an actual proposed standard for AV over IP, so everyone that would use it would do the same thing, but explain where it came from and how it works.
Well, yeah, so I think about 4 years ago, we used to go to NAB shows and InfoComm, and we had SMPTE 2110 plus NMOS plus other work we were doing, and what we learned is that SMPTE 2110 is very stable, it's awesome, but not a great fit for Pro AV, right?
Too high bandwidth. Basically, it's basically AV over IP for broadcast, uncompressed for the most part, which means that you can keep 4K, 8K at its native resolution, but it requires really high bandwidth switchers, really high bandwidth cabling, and zero problem with RF interference and things like that.
Right, exactly, right. That's where, right? So we took that base, and which is a very stable, solid base, and actually SMPTE 2110 actually has all of the flexibility needed for Pro AV. The problem is that there were a lot of shoulds when there needed to be shalls. So not a lot of broadcast devices really supported the Pro AV workspace. Plus there were some gaps. So no HDCP, no USB interoperability, no EDID support. So we took that.
Let me mention that about HDCP and EDID. The reason why that they're not in broadcast is that those are last mile things. Those are like the things you do at the end to make sure people aren't doing copy protection or messing with the original signal. The studios, they don't steal stuff, so therefore we want them to route everything without all that DRM and stuff like that.
Exactly. No, you've got it exactly right. I mean, they care about security, but they don't really care about content production at that point. So we had to make that interoperable. And so what we've been doing the last 3 years is we've been doing that hard work. We've been, and in fact, we've had the COVID, ironically, has made the progress on that actually a lot faster because people are more focused. You know, they're home doing available, that kind of thing. So we've been in the past year. Actually, we finished the timing specification. So now you don't even need PTP at all if all you're doing is going from a source and video and audio that's coming from the same source. You just use the clock for that device, right? So no PTP required for that. And in fact, even if you're using PTP for multiple source situations, it's a lot less stringent. We've made it compatible with software implementations. We've made that a requirement. So even if you're making a hardware device, you have to be able to accept a stream from a software device and vice versa.
We'll talk about software-only applications in just a second. So they kind of, I don't want to use this term loosely, but they kind of dumbed down SMPTE 2110 with only the functionality that needs to exist for corporate AV or AV applications, or how would you describe it?
You know, actually, I'm glad you said it that way because I've heard that before.
Yeah.
And what I like to kind of point out is that the Pro AV market is actually, in a lot of ways, way more sophisticated than broadcast, because broadcast, you have engineers who have the sophistication, and Pro AV, it's got to work. And that requires, yeah, exactly. I mean, the sophistication we had to build into the EDID API, in fact, is an example. You know, in broadcast, you define what you're going to send, and the device you receive will accept that, or you're just doing it wrong. In Pro AV, you know, your monitor might list 15 different resolutions, but you as the installer want to restrict it to just like 2, because that's what you calibrated for. And then somebody plugs in a laptop, and you've got to make all of that work together. And so that really requires...
It has to be automated.
It has to be automated. It has to be plug-and-play experience. And same thing with timing. You know, you have to do more in the device so that even though the source is a little sloppy, you're going to still see a picture.
So that, because in the broadcast world we need seamless switching, but in the Pro AV world, it's okay if we have a blank a little bit here and there. Yeah. So IPMX is a proposed standard. It's not been ratified yet, but it's got a lot of momentum behind it, and there's still some work that has to be done on it. But you've already gone ahead and come out with a product that it already integrates IPMX. Talk about that product for just a second.
Well, because we started with 172110, and Macnica has a long history, being actually one of the members of the organizations that created 2110. We've been able. Now we're doing it again for Pro AV, right? So. Because we started with that base, we've been able to actually create a product that we know can support the final standard. And so for manufacturers that are looking to be ready on day one, and there's actually kind of, we can't, NDAs being what they are, there's more than zero, I'll tell you that for sure. So for those manufacturers that want to be ready on day one, that want to have early products, we have our dev kit. Also, we've had a number of people that just want to try it out. So we kept the price real low. In fact, everything, including the switch, the 2 dev kits.
Let's look at this, because this is what it looks like. It's just lit up in the box here, but it's a card.
Right.
I love the color purple, of course. And it's all in one. I mean, basically, this is all you need to actually take a transmit or convert anything to network, or take everything from a network back to its original source.
Yeah, you got it right. It can encode or decode. And then you add a dev kit, add 2 dev kits that include this chip on it. For $19.50, people can start playing around.
You have a complete system, transmission, receiving system, and then you add a few more, and you got a matrix switch on there.
That's exactly right. And we've had people that have just purchased one just to keep up with it. They're not necessarily making the product right now, but they want to be ready for it when it comes and follow along with it too.
And that's Macnica.com, MACNICA.com, to get more information on it.
Oh, I'm sorry. You know what? Can I just? It's MacnicaTech.com.
Oh yes, correct. MacnicaTech.com. MacnicaTech.com. We'll make sure we get that right in the description.
Yeah.
So even if you're an integrator that's pulling multiple pieces of equipment together, you're going to be interested in following the progress of IPMX and what Macnica is doing, because it could have a big impact on the AV over IP market. The advantage of this would be anyone that adopts this, or when it gets adopted, everyone would have to adopt it theoretically, but when it gets adopted, or when it is adopted, all the products that use this will all work interoperably together. Now, let's talk about the software only, because there's some applications. Like, I can imagine one day you're sitting at your desktop and you type in an IP address, and all of a sudden all the content that's on the network is readily available to you.
Exactly.
That's a software version of IPMX.
Exactly. So imagine you're sitting in the back of a huge auditorium, and you've got, you can't see the screen very well, right? But you have a device, and sitting there, you can just, you can just dial in and receive your IPMX stream right there. That's just one example. And as we want to have more flexible systems, we want to virtualize things, we want to use the cloud. Software is absolutely part of the picture. And we, as part of the standards bodies, we recognize that, and we made sure that everything about IPMX really had a software answer, right?
Which means that you have the soft encoder that exists and soft decoder that exists, so that all the sources, whether coming from a computer or DVD player or whatever, can be put on the network and pulled back off wherever you are. And how you pull it off can depend on the bandwidth you have available to you, or the source that you're providing. Exactly. And so, like, you're in the back of a classroom and you just want to take screenshots of the notes, and you're using an iPad to do that, that gives you the ability to do that. So I see a lot of applications here. I want you to learn a lot more about them. You can go to MacnicaTech.com. Also, IPMX has its own organization.
IPMX.io.
IPMX.io is the organization itself. And again, it's based on the SMPTE 2110 standard, which is what's being used to bring every bit of TV to your house today. Thanks for watching. Andrew, thanks for joining me.
Thank you, Gary.
Thanks a lot. We got a lot more to cover. Keep watching.